Alright, in this lesson we're going to talk a little bit about Newton's law of universal gravitation. This is the definition which you guys need to know. Each particle in the universe attracts every other particle with a gravitational force that is directly proportional to the product of their masses and inversely proportional to the squared distance between their centers. Alright, let's unpack this a little bit. When we talk about particles, we talk about any object, anything from the microscopic to the macroscopic, things from dust particles, atoms, essentially to the point of planets or even universes. The gravitational force between atoms and whatnot are actually minuscule, essentially, so therefore it doesn't really apply there, but it does apply when you start talking about things which are massive, things like planets, things like suns and solar systems and universes, and they exert a force on one another, which we call gravity. Alright, now the gravitational force is directly proportional to the product of their masses. That means that if we want to talk about their gravitational force, the force will increase with mass size. So obviously, since we're talking about two particles, they must have their masses, they both have mass. And if you multiply their masses together, we get essentially a proportion between their masses and the gravitational force. And the gravitational force is inversely proportional to the square distance between their centers. That means that as the distance increases, the gravitational force will decrease, but not in a proportional way, in an inversely proportional way to the square distance. Not just the distance. The square distance tells us that if we change the distance, it will change exponentially, not in a linear fashion. Now, the equation which you need to know for Newton's law of universal gravitation is this: F being the force which will be measured in newtons, G being G, which is the gravitational constant, M 1 or 2 are the masses which are measured in kilograms, and R being the distance between the centers. Right, remember, in terms of SI, the only SI unit that actually has a prefix before it is mass, kilogram. So even though if we're talking about universal scales, we'll be using this distance of kilometers or light years, etc., the distance must always be converted back to meters. Alright. Now, in order to sort of understand what we're talking about when we talk of the proportionality of Newton's law of universal gravitation, we must actually have a look at their proportion. So if we talk about proportion, we use that sign. So the proportion of force to mass would look like that, and the proportion of force to distance would look something like that. Now, let's just say this is our old force, and we were to now double mass 1. Okay? So therefore, the new force would look something like this. 2 times mass 1 times by mass 2. So therefore, the new force is proportional to 2 times mass 1 mass 2. Now, if we take this section here, we could now say that M1 times M2 is actually the old force. So a way to explain it is now saying that the new force is 2 times the old force. This is true for if we were to double mass 2. This would be true if we doubled mass 1 and mass 2, and we would end up getting a 4 times force. Now, let's have a look at what would happen when we double the distance, double R, or the distance between the centers. So therefore, the new mass, or the new force, would be proportional to 1 over 2R squared. Right. Now, when we work this out, we get 4 r squared. Does everyone follow that? Now, the new force essentially is going to look like this, isn't it? Because we could separate these two together. Now again, we've got 1 over r squared, which is our old force. So the new force is proportional to 1/4 of the old force. Okay, I'm sure some of you didn't see that coming. But if we double distance, we quarter the force. If we double or we quadruple the distance, we would 1/8 or 1/16 of the force actually. Alright, that is what it means by the square distance. Okay, the square distance between the centers. And that is true for all of it. Now, obviously it's inversely proportional, so as the distance increases, the force gets lower. And if the distance were to decrease, let's say half distance, therefore the new force would be proportional to 1 over 2 r squared. So therefore it would have 1 over 1/4 r squared. Okay, now let's have a look and rewrite it here. So therefore the new force would be proportional to 1 over 1/4 times our 1 over r squared. So you can see again that's going to be our old force. But when we simplify this, 1 over 1/4 is going to be 4 times the old force. Okay, this is what we call the inverse square law. Alright, okay, so if you have any more questions, please leave it in the comments below. It will help a lot in order to create content for those who are actually watching.